All right, this is the third section of our geometry review, and it is on circles. Now, we didn't do a lot with circles in geometry for those last year, but some of you will have done quite a bit on circles. Now, I do want you to remember a couple things that you will need to know for this. Now, on your formula chart are these two formulas, but you need to remember that the area of a circle is pi r squared, pi times r squared, and the perimeter or the circumference of a circle is 2 pi r, or pi times d, okay, because 2r is diameter. Now, you will notice that those will be on your formula chart when you take tax. These down here are not, so you're just going to have to kind of remember about those. Now, if you remember, the measure of the central angle equals the measure of the arc that it intercepts. So a central angle is any that has a vertex here at the center of the circle. So each of these, RO, UO, OT, and OS, are radii. Okay, so all of these have angles that have a vertex here at the center of the circle. Now this one is 90 degrees, 140. We don't really know what these are, but using this theorem, with the measure of RU here, the measure of the angle of central angle is 140, so the measure of arc must also be 140. Okay? And arc measures are also in degrees, so this is going to be 140 degrees. Now, a minor arc, one that's less than 180 degrees, is named with just 2 letters. If we were talking about the arc that goes from R to U over here, that's a major arc, and it would have to be named with 3 letters, either RSU or RTU, so that we knew to go the other way around the circle. So that's how you know which arc they're asking for. Angle, ROS, here, we don't know the angle, but we do know that the arc length is 90, and this is a central angle, so that means that that angle is also 90 degrees. Okay. Measure of arc ST. Well, we don't know this, but we do know that all the angles in a circle add up to be 360 degrees. We know this symbol means that that one's 90. So we have 2 90-degree angles. That's 180 plus 140 is 240. No, 220. So that means subtract that from 360, and angle ST must be 40 degrees. Okay. Now the measure of angle ROT. Well, we don't know this one, but we know that arc ST is 40 degrees. So that must mean that this angle is 40 degrees. And so our angle ROT is 90 plus 40. Or 130 degrees. Okay. Now, measure RUT, which you notice this is an arc named with 3 letters, so it's going to be a major arc. So it's going to go from R to U all the way around here to T. So we know that this is 140, this is 90, across from this 90-degree angle. So the measure of our arc, RUT, is 140 plus 90, or 230 degrees. Okay. Now, find the measure of arc AB. Well, we have a triangle inscribed inside a circle, and we know that all of the angles of a triangle add up to be 180, but these are not labeled. But we do know that AO, line segment AO, and OB are radii. Therefore, they are congruent. Okay? So that means that this and this are the same length, so that angle must equal this angle, because an angle across from the side, if they're the same length, if the sides are the same length, then the angles are the same length. So we have two 40-degree angles. All the angles in a triangle add up to be 180, so that means this one must be 100 degrees. So the measure of angle AOB is equal to 100 degrees. So because that's a central angle, then the measure of arc AB is equal to 100 degrees. Okay, so you have to kind of get the hang of the arc length. Now, when an angle, just in case you run into this, if you have an arc that's described by an angle that goes all the way to the other side of the circle, this angle measure is half the arc length. So if this was a C, that angle is 50 degrees. So angle ACB, which they don't ask for, is equal to 50 degrees. It's half the arc length. That's just something you might need to know at some point. Now, the next section on this little piece we're doing here, down here, these are really pretty much ratios and proportions. The length of the arc to the circumference of the circle is the same proportion as the measure of the arc to 360 degrees, because, you know, if if the angle's going around, if a central angle equals the arc, and a circle, all the angles in a circle add to be 360, well, an arc, all the arcs add to be 360 as well. So we're looking for GH. Well, we know this arc length is also 80. We know that the radius is 6 meters. So looking at this formula, the length of the arc, that's in meters, okay, over the circumference of the circle. Well, the circumference is equal to 2 pi r. So that's going to be 2 times pi times 6, or 12 pi. Okay? So we can say the arc length of GH, the measure of the arc, GH, over 12 pi is equal to the measure of the arc right here. We're looking at this formula. The measure of arc, which is 80 degrees, over 360. So again, it's a proportion. The length of the arc times the length around the whole circle is equal to the angle measure of the arc times the angle measure around the whole circle. And so to solve this, then we have the arc length of GH is equal to 12 pi times 80 over 360. And we're going to go ahead and put that in the calculator. Use the pi button in the calculator. And we're going to get a measure of 8.4 meters. Okay. So that was a pretty simple ratio and proportion. And what we're going to do for the rest of this worksheet is a ratio and a proportion. So let's move on to the next part. Go down all the way. Okay. Janie planted a circular flower garden with a 15-foot diameter. So now we know the diameter of this circle as shown below. Find the length of the arc of the section containing the daffodils. So we want the arc of this section right here containing the daffodils. Okay. All right, so now we need the circumference. So circumference is pi times the diameter, which is 15, if we know the diameter. Okay, the length of the arc, so I'll say arc with daffodils. Okay, just a minute, I need to get rid of this just a minute. I gotta do something. Okay, sorry about that. Back. So we did the circumference, and I'll write that back up there is 15 pi. Okay, so the length of the arc over 15 pi is equal to, now we have to figure out the measure of this arc. And we know it's going to be over 360. Okay, so we have 200 plus 95. So the measure of this angle is going to be 65 because it has to add up to be 360. And so that means that this arc length is also 65 degrees. Okay, so to solve it then, we have 65 times 15 pi over 360. You put that in your calculator using the pi button, and it says round it to the nearest foot. So we have 8.508 is what we get, and that's going to actually round up because it's bigger than a half. So that's going to round up to be 9 feet. So be careful on your rounding, especially something like that. All right. Now the area of a sector. Now if they wanted the area that these daffodils were planted in, that would have been the area of a sector. It's usually a shaded region. Okay. So what is the area of the shaded region to the nearest whole number? So we're finding the area of the sector of a circle. So again, a ratio. The area of the sector in relation to the area of the whole circle is equal to the central angle over 360. Real similar proportion is just that instead of circumference, we use the area formula. So area of the circle given is pi r squared, and the radius is 3, so it's pi times 3 squared, or 9 pi. Okay. Now putting in the formula, the area of the sector over 9 pi, which is the area of the circle, is equal to the central angle, and they give us that, that's 70 over 360. So to find the area of the sector then, it will be 70 times 9 pi divided by 360. And we're going to put it in the calculator. And we get 5.498, probably on and on. We want it to the nearest whole number. Now notice this is less than 5.5. Even though 4.9 would round up to 5, and then you could say it would, or 498 would round up to 5. It's as it is. That's what I mean, don't round when I say often, don't round too soon. This is less than 0.5. If you rounded it and looked at it, you might say, okay, I need to round it up to 6. But don't do that. Look at it like this. And so we're going to end up leaving it at 5 for our rounding to the nearest whole number, and it's going to be 5 square centimeters because area is a square. So the area of the sector is 5 square centimeters. Now it says use a ruler to measure the radius OB of the circle shown below to the nearest tenth of a centimeter. Well, it's hard to do that on the computer, but you're going to have to trust me that it measures about 2.5 centimeters. Okay. So we know the radius, so we can find the area. Area of the circle is pi times 2.5 squared, which is equal to 6.25 pi. All right, so the area of the sector then, and what they want the area of sector AOB. That means that's this part right in here. That's what they want the area of, okay? That sector, not this big sector. They could ask for that, but that's not the one they're asking for. So, area of the sector is equal to, area of the sector over 6.25 pi over the area of the circle is equal to this angle, which is 80 over 360. Okay? Then when we multiply, you have 80 times 6.25 pi over 360. Okay? And then it says find the area to the nearest tenth, and so we're going to say that the area of the sector, put a little s there, area of the sector is equal to 4.4 centimeters squared. Again, because it's area, it's square centimeter, square unit. Okay, that is the end of this little section on circles.